So we're going to practice solving differential equations, and we're going to use separation of variables to do that. So if I start with the differential equation, dy dx equals 2x plus 3. Step 1 is to separate the variables. I have y's and x's on the left and x's on the right, so I'm going to take this dx and multiply it over to the other side. So I should have dy equals 2x plus 3 dx. I put y's on one side, x's on the other. Step 2, I'm going to put my integral symbol, saying I'm going to take the antiderivative. On the left, the antiderivative of the derivative of y is just y, equals, now I'm going to actually undo the power rule here. So I'm going to add 1 to the exponent, so it's a 1 right now, it's going to be an x squared. Then divide by my new exponent. When I divide by 2, that cancels out and I'm left with just an x squared. Right now, this 3 is like it has an x to the 0. So when I add 1, I get x to the first, which is just an x. Divide by my 1 and it's plus 3x plus c. You want to check by taking the derivative. The derivative of y with respect to x is dy dx equals 2x plus 3. So that's my answer. For the next differential equation, let's say we have dy dx equals y squared. Step 1 is still to separate the variables. So my dy and dx both need to be in the numerator when I do this. So I am still going to take my dx and move it to the right. But what that means is that I need to get this y squared to the left. So I'm going to divide by a y squared. So this will be 1 over y squared dy equals a dx. I take the antiderivative of both sides. And this one I'm going to rewrite. This is the antiderivative of y to the negative 2 dy. And if it makes you feel better here, you can say that this is a 1 dx. The antiderivative on the left, I'm undoing the power rule, so I'm going to add 1. It's y to the negative 1. Then I'm going to divide by my new exponent, which is a negative 1, and it makes it a negative, equals. Then over here, I have a 1. That's like having a 1x to the 0, so I'm going to add 1. It makes it an x to the first. Divide by 1, I'm just left with 1. And then you'll notice I didn't put a plus c over here. Well, that c is a constant of integration. It can represent any number I want. I'm going to put it over here. I could have had a plus c and a plus, like a plus c sub 1, a plus c sub 2, but in the end, my goal for solving a differential equation is to get y equals. That is your goal. So the first thing I would have done would be move the c's over and combine them. So I'm just going to leave one big capital C here for my constant of integration. This I need to solve for y. So I'm going to rewrite it without the negative exponent. So this is a negative 1, and then that's y to the first, but underneath, equals x plus c. So my goal is to get y equals. And just a reminder that if you get lost in solving, most things in this class can be done either through factoring or cross multiplying, but I need to get this y in the numerator, so I'm going to move it over. If it helps you to think about it, think of the x plus c over 1. So I'm going to multiply both sides by y, and that leaves me with a negative 1 equals negative 1 times 1 is your negative 1, x plus c times y. Well, if I'm trying to get y by itself, I can divide both sides by an x plus c. That cancels out, and I'm left with the solution of y equals negative 1 over x plus c, where c is some constant of integration.